Hello. In this video I'll be talking about a topic called integration by parts. Give me 1 second. I need to get the right zoom. Here we go. Integration by parts. And generally this will be one of the first concepts you'll cover in a Calc 2 course. So if you haven't finished Calc 1, this video might not make much sense to you. But what integration by parts helps us with is the integral of basically a product of functions. So it's a little like product rule in a way, but for integration. And to find out what this integral is, we first start with the product rule, actually. So this is kind of the proof for integration by parts, which I'll actually show you because it's not too complicated. So let's say we had f of x times, I'll do big G of x. And what big G is, if you don't know, it's basically the antiderivative of g of x. Right? So it'd be basically like the integral of gx. But we're not worried about any initial conditions until the very end. So following product rule, that would equal f prime of x times big G of x plus f of x, and then the derivative of g of x would be g, right? Because, or like big G of x would be small g of x, because that's the antiderivative. So we start with this statement, that the derivative of f of x times big G of x equals f prime of x times big G of x plus f of x times g of x. And then if you think about the fundamental theorem of calculus, we can take the integral of both sides. And for the left, taking the integral of that would basically undo the derivative, right? So what we'd be left with is just f of x times big G of x. And then that would equal to the integral of f prime of x times g of x, big G of x, plus the integral of f of x plus g of x. And now before we continue, we're going to redefine f and big G of x. So we'll say u equals f of x and v equals big G of x. And then we'll also find f prime of x. So differentiating with respect to x. We have du dx equals f prime of x. So we'll actually solve this for du. So we'll say du equals f prime of x times dx. And we'll do the same thing for dv. So first we differentiated with respect to x, and then we just multiplied over that dx. So now we'll substitute in these values into this equation. So uv, right, equals the integral of, so we have f prime of x here in dx, so we can take those two and substitute in du, and that's multiplied by v, right? So that's v du and then we can do that same thing with this next one, but now we have g of x times dx, which is dv, and we have f of x, which is u. So that is u dv. And then basically we want to solve this equation for this integral, because that's what we started with, right? That's the one we're trying to look for. So basically we say that the integral of u, or f of x, dv, or g of x times dx, equals uv minus the integral v du. So now I think we should run through a sort of example here, just to kind of show how it's used. So let's say we had the integral of x times cosine x times dx. So basically we have to kind of find which function should equal u and which function times dx should equal dv. And it comes to this acronym called LIPIT. And what LIPIT does, it helps us find which function should be used first to be substituted as u. And it's basically, it was derived to kind of show which functions will become simplified by u, so that when we take the integral, we don't have another integral of product of functions. So LIPIT stands for logarithm, so kind of like ln function. So you start with any ln function. I stands for inverse, so think of like inverse trig function. P stands for polynomial. E stands for exponential, think of e to the x. And the T stands for trig. And in fact, the e to the x and trig functions can be swapped. it ends up being that you can use either one for u. So since x, which is a polynomial, comes before cosine, which is trig, we will have x equal u, and we'll have cosine of x times dx equal dv. So we have u and we have dv. And if you look at this formula, we need v and we need du. So to find du, we will take the derivative of this kind of relationship. So x equals u. So we'll take the derivative with respect to x and then multiply over that dx variable. So we have so we have 1 equals du over dx. Or we can just say that dx equals du, right? And I'm sorry, I kind of forgot the dx here. So then with the dv, all we need to do is just integrate both parts to find v. So the integral of cosine of x times dx is sine of x, right? And the integral of dx equals v. So now we have all these parts, and we plug it into the formula. So we have u, which is x. We have v, which is sine of x. And this is subtracted by the integral of v, which is sine of x, times du, which is dx. Now you see we have this more simple of an integral. So we then have to integrate the sine of x. Which ends up being negative cosine of x, right? But since we're subtracting a negative, it turns into addition. So we get that the integral of x times cosine of x is equal to x times sine of x plus cosine of x plus c, right? Because now that we're done integrating everything, we can add that initial condition. And that is integration by parts. And we were fortunate enough to be able to derive it. This actually ends up being one of the easier calc concepts so that we can show the actual proof behind. So thank you for watching and keep learning.